Hey everyone, you're watching Space Channel. Recently, in the comments section of one of our videos, a subscriber asked me, what would happen to Earth and to the universe as a whole if gravity were to suddenly disappear? And what would the universe look like if gravity had never existed from the very beginning? As our regular viewers have probably noticed, I enjoy answering all kinds of hypothetical questions, even when the scenarios they describe are impossible to execute in the real world. I find this question pretty fascinating, and I've heard a lot of different answers to it. Most people focus on gravity's effects on humanity and what happens at Earth's surface, or they treat it simply as the force that pulls planets and stars together. From that angle, they'll say that if gravity disappeared, planets would fly away from their stars, galaxies and their clusters would fall apart, and everything on Earth's surface would float off into space. However, gravity is responsible for many more processes in nature, and the consequences of its vanishing would be much more severe. What exactly would that look like? Let's break it down together. Here's the thing. Gravity doesn't just hold planetary systems and galaxies together. It's also responsible for the formation of planets and stars, and it keeps them stable. Since the subscriber's question has two parts, and the answers are closely connected, let's start with what our universe would look like if it had no gravity at all. When the universe had just formed, it was filled with particles almost uniformly, and slight variations in density were driven by various quantum processes. Those irregularities were simply regions where atomic nuclei, and later the first atoms and molecules, sat a little closer together than the rest. A newly formed molecule, perhaps the only one for thousands of kilometers around, would, thanks to gravity, have a slightly stronger pull than the surrounding atoms and become a tiny focal point for nearby matter. As a result, it would gradually draw the nearest atoms toward itself with its minuscule gravitational pull. As they moved closer, the density in that region would rise a bit more. That patch would then stand out even more from its surroundings due to its gravity, pulling in fresh atoms, atomic nuclei, and electrons, and later other molecules, even faster. This went on for hundreds of millions of years. The irregularities grew, pulled toward one another, and merged, forming enormous gas and dust nebulae. Gravity continued to compress these nebulae. Smaller clouds split off from them and continued collapsing under gravity until nuclear fusion began in their cores. In this way, approximately 400 million years after the universe was formed, the first stars emerged and illuminated the cosmos. And gravity kept on creating new clouds and new stars right up to the present day. It also made the leftovers of those protostellar clouds gather into planets and their moons. As you can see, all of this was only possible because of gravity. If it didn't exist, those irregularities couldn't have grown. Atoms and molecules would have repelled each other as they came close, and then flown apart again. Gravity, however, acts only as an attractive force, which is why it has driven the formation of every structure in the universe. Without gravity, the universe would have remained an extremely tenuous gas, looking much like the interstellar medium, basically empty space with only a few atoms per cubic meter. For comparison, the number density of air in Earth's atmosphere near the planet's surface is about 3 times 10 to the 25th power, that is, roughly 30 septillion particles per cubic meter, only about 5 to 10 septillion times higher. And remember, Earth's atmosphere is mostly nitrogen and oxygen molecules, while space is filled with hydrogen and helium atoms, which are much smaller. If we expressed the atmospheric concentration in terms of pure protons, the nuclei of hydrogen, it would be about 30 times higher still. All right, we've settled the question of a universe with no gravity from the very beginning. But what would happen if tomorrow gravity suddenly vanished? Let's first look at what happens inside most stars, excluding white dwarfs and neutron stars. As many of you know, Stars undergo thermonuclear reactions, in which lighter nuclei fuse into heavier ones, releasing an enormous amount of radiation, that is, photons. It's also well known that the pressure at a star's core is immense, but fewer people realize that one of the main contributions to that pressure is radiation pressure. We usually don't notice it here on Earth because it's tiny, but you can do a simple experiment. Place a sheet of paper with writing on it under direct sunlight and cover part of the writing so no light reaches it. After a few months, the exposed portion will fade, or even disappear, which is the result of light's pressure on matter. Inside a star, the radiation is so intense that its pressure becomes the dominant force. As a result, ordinary stars exist in a stable state thanks to a delicate balance between gravitational pull, which tries to compress the star, and radiation pressure, which tries to tear it apart. The situation is similar for neutron stars and white dwarfs. Still, since thermonuclear reactions no longer occur in them, the main outward support comes from centrifugal force and the pressure of degenerate neutron and electron gases, respectively. It isn't hard to imagine what happens if gravity drops out of this equation. Radiation pressure would simply rip stars apart, much like what we see in a supernova explosion. The details would, of course, differ, but to an outside observer, the scene would look very similar. A person hanging somewhere in the middle of our galaxy would see the surrounding stars flare up and then disappear one after another, transforming into something like a planetary nebula. That sequence would be set by the finite speed of light. It would reach the observer with a delay proportional to each star's distance. So after gravity vanished, distant stars would still look unchanged for thousands, millions, even billions of years. In fact, if someone were out in intergalactic space, they might not notice gravity's disappearance for a long time after it happened. What about planets? There are a few possibilities. Giant planets with fluid interiors also have enormous internal pressures, so they'd be almost instantly torn apart, much like stars. Planets with fully solidified interiors would break up more slowly because their core pressures are much lower and they have some built-in structural strength. They'd gradually fracture into pieces. Dwarf planets and asteroids could survive intact, since their material strength would exceed the internal pressures. Finally, of course, everyone wants to know, how would black holes behave? You might think they'd just disappear, but in reality, it would depend on exactly how gravity vanished. The thing is, inside a black hole, gravity stops being a consequence of the matter there. It becomes a property of space-time itself. I've never seen research on what would happen to a black hole if gravity were to stop working, and a comprehensive analysis would take me years. So unfortunately, I can't say what would happen to black holes. If you enjoyed this video, hit like and subscribe to the channel. Thanks for watching. See you next time.